Limit the number of people per team to 4. However, during the checkpoint meeting at the beginning of IAP, 5 people showed up to the meeting for this team. And I was a little confused because only 4 were registered for the course. What I found out happened is that one of their friends decided that building robots was so much fun that they were just going to help the team build their robot over IAP. And so that's why this team has 5 people. Do you want to introduce the members?
Sure. So as Val already said, we have 5 team members. They're awesome. 3 people were working on the mechanical engineering stuff, and 2 people were working on programming the robot. Matt, who is preparing the robot for the course, is one of the greatest programmers I've ever known. He's just awesome. We couldn't have really accomplished anything without him. And like, you know, we couldn't have really accomplished anything without a single member of the team. Everybody contributed.
Okay, so it's starting out, what's it doing?
Now it's trying to look for balls. So it seems that it picked up one. Now it's going to align with it.
So I know that your team detects balls in a fairly unusual way, right? I think you use neural networks to learn what was red. Is that right?
Yes, we are using the RGB color space, and we thought that, well, this color space is best suited for colors like blue, green, and red. And so we had a bunch of test images, and we thought that the best way to get the actual values, how much each color component counts, is to feed the images into a neural network. And this is how we got the values. I mean, it works pretty well. I mean, it did work pretty well. We will see how it performs on the actual course, but I hope it will go well.
Okay, so most teams set like a threshold for values to tell which are red and which are blue and which are green colors. This team actually used statistical learning to figure out what exactly was red. So can you tell me why your camera seems to be mounted on several things?
Our camera tracks the ball as the robot moves and tries to pick it up. We are not using any complicated math and not relying too much on other sensors besides the camera. So when the robot is going and trying to pick a ball, it does not compute the actual angle because of the gyro noise and other unexpected things. What it does, it tries to keep that ball in the center of the image.
So can you tell me what sensors your robot uses?
The robot uses the camera and 3 IR sensors. We use the IR sensors for wandering around and for wall following.
So does it know how many balls it has, or will it just continue to keep collecting them?
It keeps track of the number of balls it has. I mean, it missed this one because it thought it was too close to the wall, so it was too risky to go and pick it up. Because we encountered some problems with the gate. Sometimes when the robot bumps too hard into a wall, it may get stuck. So we decided it's safer to just leave the balls that are really close to the wall. And our primary objective is to collect as many balls as possible and then dump them into the goal. But only if the goal is visible.
So do you use a timer, you collect balls for a certain amount of time and then look for a goal? Is that what you do?
Every time the robot is looking for a ball, I mean, it wanders for a certain amount of time. Then when wandering times out, it tries to look for balls. If it can't see any balls around and has at least one ball inside, then it tries to find a goal and score.
What is it doing now? What do you think happened there?
To be honest, I don't know. So it went really close to a goal. It knew that it had at least one ball inside, but first it starts looking for balls. So it saw the balls in the distance, and that's why it didn't go for the ball.
Do you think it has a chance for going for that goal there?
We'll see. So it is looking for a goal now. No, it's still following now. It looks like it's got some problems with seeing yellow. I don't know why.